Welcome back. We are going to be covering 1.2, functions and graphs. We're in college algebra and I wanted to go over the difference between a function and a relation. And actually, if you take a look here, I have a graph of them. Functions are a subset of relations. So it's possible for a function, or it is required, in fact, for a function to be a relation, but it is not required, and not all relations are going to be functions. And we're going to talk about what that means and why that is. All right, so functions versus relations. A relation has at least one output, whether we call in the case of y or f of x, a range or dependent variable. For every input, or our x's domain, our independent variable, a function has exactly one output for every input. So the difference here is whether you have exactly one or more. All right, so by definition, it's pretty clear that a function meets the criteria of at least one, but it doesn't allow for any more than one. So there's a smaller group of functions than there are of relations. So more formally, this is the formal math language on this. A relation is a correspondence between the first set, called the domain, and the second set, called the range, such that each member of the domain corresponds to at least one member of the range. A function, on the other hand, is a correspondence between the first set, called the domain, and the second set, called the range, such that the member of the domain corresponds to exactly one member of the range. All right, so keeping track of domain and range has always been a little bit confusing for folks that I've encountered. It was confusing for me for a while until I came up with this mnemonic. So you go to the doctor for an x-ray, and the D here is going to go with the X, and the R goes with the Y. And if you don't care for that method, you can always think about domain and range, right? That's in alphabetical order. And then your X and Y is also in alphabetical order. So the D goes with the X and your R goes with the Y. All right? Same result ultimately. All right, so let's take a look at some relations here and decide whether or not they could be a function or not. All right? If it's only a relation, we're going to call it a relation. If it's a function, rather than saying it's both a function and a relation, we're just going to call it a function, but just realize that it is actually both. All right, so in this case, we have the example, right? We have an example of x and y, where we have 1 and 1 are corresponding, and then 1 and -1 correspond, and 4 and 2, and then 4 and -2, and I have 9 and 3 and 9 and -3. So since this number, this 1 and this 4 and this 9 are all the same numbers, right? I mean, this is like one set of numbers, it's 1, this is really 4, and this is really 9. I have more than one answer here, right? I have this answer, right? And remember, this is really just the same number. So you may have to look for it. So, and then we're going to have this one. So I have two solutions related to the number 1. They are not the same solution. So right now, before we go any further, we can already say this is a relation, not a function. All right, on this next one, I have -3, I have -3 and 9, -2 and 4, -1 and 1, 0 and 0, 1 and 1, 2 and 4, and 3 and 9. All right, so for each of these, I don't have any duplicate answers here. I don't have any duplicate inputs. And for each answer here, I have exactly 1. So this is going to be a function. right? That's the second one here is a function because there are no duplicates here and there's no answers that attach to more than one of our answers or one of our inputs. Here I have one again. I'm going to have to take a look. I'm taking a look and I have 2 here and I have a 2 here. All right, so these 2's, my gut reaction at first seeing those 2 2's is going to be like, oh, this has got to be a relation, not a function. But if you take a look, this 2 says our output is a 9, and this 2 says our output is a 9. Is that the same answer or a different answer, right? And the answer is that it is the same answer. So just because it shows up in the list twice, if it has the same value, it is not indicative of a relation or just a relation. This is actually going to be a function, right? Because I have exactly the same answer for each input, right? So I have this 2 and this 2 have exactly the same answer, so it's really just one answer. All right, so here's one, and this is a little confusing. It throws people sometimes because I have, for -2 I have a 4, for -1 I have a 4, for 0 I have 4, 1 I have a 4, 2 I have a 4, and 3 I have a 4. All right, so what does it say about our equation or our relation, right? If we have a relation, we can have more than one answer for each input. And if I have a function, I have exactly one for each input. So people look at this and say, oh, well, this is all 4, so this has to be, of course, a relation. It's not going to actually be a function because they're all the same value. But if you stop and think, here we're talking about the x's having more than one answer, not the y's having more than one input. Okay, so here I have exactly 1, and 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 here I have exactly 1. So these are all going to be one answer, even though it's the same answer all the way along. It's going to be one answer for each of these inputs. So this is actually a function. I tend to kind of, occasionally I trip people up with that, and I want to make sure that folks are really clear when it is a function and when it is not. All right. So let's take a look at this. I have 1 and 1, 2 and 2, 3 and 5, 4 and 12, 5 and 27, 6 and 58, and 7 and 121. All right, so here I have no duplicate inputs, and I have none of them that give me 2 answers. So this is going to be a function, right? This is a function, pretty straightforward. If we take a look here, I can see that I have a 1 and a 2 and a 3 and a 4, 5 and then a 4. So let's take a look. I have a 4 here and I have a 4 here. Now our first gut reaction would probably be, oh, this is a relation. But we actually have to double check our output. Is our output different from one to the other? So in this case, this 4 gets me to 16 and this 4 is saying 64. So yes, there is in fact a relation here rather than a function. All right. So again, I'm going to have my numbers. I have my inputs as 1, 2, 3, 4, 5, 4. All right. So again, I'm going to take a look here. I have a 4 there. I have a 4 there. And if I take a look, this 4 gives me a 12. And this 4 gives me a 12. So is it the same answer? Yes, it is the same answer. Is every other number, do I only have one solution for each one of my other inputs? The answer is yes. So in this case, it is a function. All right, I am going to pause the video here and pick up again here in a moment.